Everyone, in this video, I'm going to go through question number 2 from the 2010 AP exam. And so just like all, if not most of the problems in this data or in this practice set, we're looking at a table of values here. In this case, we're looking at a table that's giving us information on the number of entries that are being submitted to name a baby elephant. So let's see what we need to do. First question is saying use the data in the table to approximate the rate at which entries are being deposited at time t equals 6. So the rate at which entries are being deposited at time t equals 6, that would actually represent the derivative. If I'm trying to find a rate at a specific point in time, that's the derivative. Now, because we don't have a function, we're going to use average rate of change or the slope to estimate that. So we're going to take the closest interval around time t equals 6 and use that for our data. So we'll take e of 7 minus e of 5 over 7 minus 5, or 21 minus 13 all over 2, which is 8 over 2, or 4. And that's going to be, since my units are hundreds of entries, we really have 400 entries per hour. All right, so that's all we had to do there, just estimate that derivative. So that was a 1-point piece of that question. All right, for part B now, it says at 8 p.m., so after kind of the data collected here, at 8 p.m., volunteers began to process the entries. So after they've all been collected, now volunteers are processing them. And they process them at a rate modeled by this function P. So P is a rate, and it's measured in hundreds of entries per hour. So we're asked first to evaluate that integral. So we're going to integrate 8 to 12 of P of t dt. Now here, this is just going to become for us a calculator question. You guys have a calculator in this year's exam, so we don't need to bother going through and finding the antiderivative by hand. Now, unfortunately, I don't know how to put a calculator on the screen here, so I'm going to go ahead and do this in my calculator. I would recommend that you do the same thing and make sure you get the same answer as I do. So when I put that in, I get 16, and the units on that would be 1,600 entries. So that was the first part for evaluating it. Now I need to explain the meaning. So remember that P of t here was a rate. When I integrate a rate, I get the change in amount. So what it's telling me is this is the change in how many entries were processed. So for my explanation, I would say, let's see, 8 to 12, the integral from 8 to 12 P of t dt represents the number of entries processed over the time interval from t equals 8 to t equals 12, and the units there were hours. In terms of points, now this we modified actually from the actual question that was on the exam due to changes to this year's exam, but typically you would get 1 point for evaluating the integral and then 1 point for the interpretation. All right, then the last part here says, according to the model in part B, at what time were the entries being processed most quickly? Right? So when they're asking us what time were the entries being processed most quickly, they're looking for the maximum. So the absolute maximum of our function. So what we're looking at here, we're still using this function P of t. So I'm going to go ahead and copy that here. So P of t was t cubed minus 30t squared plus 298t minus 976. So that's the rate that they're being processed, and I want to know when that rate is the greatest. When are they being processed most quickly? So to find an absolute max, the first thing we have to do is find our critical points, which we do by taking the derivative, which is 3t squared minus 60t plus 298, and then we set that equal to 0. Now, since we have our calculator here, the most efficient thing to do would be to type your derivative, our p prime of t, into your y equals. Once you've typed that into y equals, so I'm going to make some notes here since I can't show you on the screen. All right, so I'm going to say type into y equals, and then you're going to use the calculator to find the zeros. Now, if you're having trouble with any of this calculator stuff, please make sure you reach out to your teacher so you're clear on how to do that come test day. So if I do that, I did this already. I get t is approximately 9.184 and then 10.817. So now what I need to do is I need to make my options table here. So I'm comparing the t and then p of t. Now I'm going to make a note here in our options table. Remember that we need to include our critical points and the endpoints. So since this model from part B, that went from the endpoints were 8 to 12 hours, and then I'm going to put my critical points, 9.184 and 10.817. So then I would just use my calculator. I'm going to take these values in t and plug them into my original function p of t. So here I get 0 when I do that. And again, please put this into your own calculator to verify you get the same answers. Here I get 5.089. Here is 2.911. And then at 12, I get 8. Now, the nice thing with this type of question where we're finding a global max or an absolute max is that this is one of the few times where your work counts as your justification. So now all we have to just state is where that maximum occurred. So I would say that, entries, I'm going to write it over here. How is this? Let's see. Entries are being processed most quickly at time t equals 12 hours. And then again, our work here in our table is going to be our justification. So for this one, they gave 1 point for knowing to take the derivative and set it equal to 0, 1 point for getting those critical values, and then 1 point for identifying the max. Again, please, if you have questions about any of the mechanics with the calculator, make sure you reach out to your teacher so that we can help you before the exam. All right, thanks.